there class, and welcome to Physics 101. And today we will be doing supersymmetry.
But first, let's be clear. Supersymmetry is a proposed theory, but it has not yet been proven, which means that it may be wrong, but that's no reason not to learn about it.
Now, to understand supersymmetry, we first have to look at regular symmetry.
We already know what symmetry is.
We learnt it years ago. That's symmetrical, and that isn't.
Well, correct. Those objects are symmetrical. But really, symmetry isn't only for objects or shapes. All that symmetry really means is that when a transformation is made to a physical system, the physical observables are left unchanged. Now, that's a bit confusing. What it actually means is if I change something, something else has to stay the same. For example, think of a square. If I rotate it 90 degrees, that's the transformation. The overall shape of the square stays the same. That's the observable. But we just said that this doesn't need to do with shapes. There's many different types of symmetries, and they don't all relate to shapes. Some symmetries can be applied to things like laws of nature.
Alright, more than just shapes are symmetrical. But what's supersymmetry?
Supersymmetry is symmetry between mass and force. What does that even mean?
Do you remember the Standard Model? It describes all the fundamental particles that we know of. And there's two distinct groups. The fermions, that's the matter particles.
That means that they make up things like protons, neutrons, and atoms. Everything that we're made of.
And the bosons, the force-carrying particles.
Which are responsible for things like gravity and light.
According to supersymmetry, each boson has a partner fermion particle, called a superpartner, which it is symmetrical with, and each fermion has a boson superpartner, which it is symmetrical with.
This is what it means by unifying mass and force, being able to relate a matter particle to a force-carrying one. In the simplest theories, this would mean that the superpartners have the same properties, such as having the same mass and internal quantum number.
This is why supersymmetry is so important. It unifies these two very different types of particles. But the thing is, no particles have yet been found that are the superpartner of any other particle. That means that there must be more particles we don't yet know of that are the superpartners of the particles we do know of.
My head is spinning. There are even more particles?
And haven't you found them yet?
Well, yeah, it's quite complicated. Don't worry if you don't quite understand it. Now, didn't you two have homework?
Yeah, we will see you tomorrow. Yeah, bye.